Hi everyone, I'm your host, Jacqueline Howard. Thank you for joining us for today's virtual field trip, Powering the Planet. This virtual event is made possible with generous support from Lowe's. So, let's talk about energy for a moment. We all use energy every day. Energy powers our cars, our toasters, our flashlights, and even our televisions. All of you are watching today through a computer screen, or maybe a whiteboard, and that's plugged into a source of electricity that keeps your school running. So you see, it's pretty amazing when you stop to think about it. But here's the big question we're going to explore today. How can we get the energy we need to power our lives without harming nature? We're going to be traveling to two stunning locations to learn how people are harnessing renewable energy resources, such as wind and sun, to do exactly that. First, we're going to visit the Palmyra Atoll in the Pacific Ocean. It's one of the most spectacular marine wilderness areas on Earth. Now, Palmyra has a fascinating history. A pirate ship loaded with treasure was once wrecked on its shores. It was used as a naval airbase during World War II, and stowaway rats on ships once invaded the island and almost destroyed the entire ecosystem. Now Palmyra is a center for scientific research and is populated with many cool species, such as coconut crabs, fairy terns, and red-footed boobies. And it's a pretty incredible place. Then we're heading to the Mojave Desert, which spans almost 48,000 square miles, and it's home to creatures like the chuckwalla, a type of lizard, and the Mojave green rattlesnake, a venomous pit viper that you probably only want to meet through your computer screen. We'll go back to the Mojave Desert in a little bit. Now it's time to get a sneak peek at Palmyra. Joining us live is scientist Alex Wegmann, the director of the Palmyra program, and he'll be answering some of the questions you have and sharing his incredible experiences. So let's meet Alex. Hey Alex, can you tell us about your background and how you became a scientist?
Hi Jacqueline, and hello to all of our viewers out there. I grew up on the border of Olympic National Park on the Olympic Peninsula of Washington State. As a kid, curiosity was a constant companion. Every time I went outside, I wondered things like, what's under this log? Where do the Canada geese go in the winter? Is a mushroom a plant? When I got to college, I wanted to learn more about humans, so I decided to study cultural anthropology. Like many college kids, I changed my major a few times. Then I had an experience that changed my life. I spent 5 months on Laysan Island in the northwestern Hawaiian Islands, studying monk seals, seabirds, and plant habitat restoration. That's when I realized how much I loved nature, just like when I was a kid. I joined a graduate program in botany at the University of Hawaii. Botany is a study of plants. Part of my research focused on the crab species at Palmyra, and now I'm the director of the Palmyra program. I've really come full circle, and I'm so excited to share the place with you all.
We're excited too. Thanks so much, Alex, and it's so great that you could be with us today. First, I have a question for you. It's a little pop quiz to get us started, but don't worry about getting the right answer, and typing just a word or two is perfectly fine. Are you ready? How do we get energy? Start typing out your ideas. Now, while you're taking a moment to type your answers, let's introduce a classroom of 6th grade students who are joining us all the way from Somis, California. They're going to be helping us out and asking some questions of their own later in this event. Let's say hello. Hey, classroom.
Hi.
Thanks, everyone. I'm so glad you could join us today. Now, let's take a look at some of the ideas that have come in about where we get our energy. And this is a great list. I see gas, oil, coal, the sun, fire, windmills, waterfalls, and candy bars. Okay, you already know a lot. We're going to learn a lot more today about different types of energy, so stay tuned. I have one more thing to share before we get started as well. For the second time, we're going to be playing a game during this virtual field trip. If you joined us last time, you'll remember it. We call it Nature Spy. We sent your teacher a list of things to look for during this field trip. As you watch, note on your handout when you see something from the list. Keep those eyes open. After the field trip, you can also play Renewable Energy Spy in your community. Now let's start our trip to the Palmyra Atoll. Alex, what can you tell us about this place? And what exactly is an atoll?
Well, an atoll is an island or a series of small islands closely spaced together, formed by a ring-shaped coral reef encircling a lagoon. At Palmyra, these coral formations are growing around a rim of an ancient sunken volcano. There are 25 heavily forested low-lying islands that make up Palmyra Atoll. The land part of the atoll, the area that you can walk around on, is only 680 acres, but there are 16,000 acres of surrounding lagoons, coral reefs, and submerged land that support a complex web of life. This place is incredibly isolated. The closest city is in Hawaii, about 1,000 miles away. Only about 20 people live and work on this tiny island at one time. This includes research scientists from all over the world, as well as staff that keep the research station running. I have the pleasure to work at Palmyra, and it's really a beautiful and unique place.
It sounds like a beautiful and spectacular place. So can you tell us a little more about the animals that live on the Palmyra Atoll?
Of course. Let's start with this really cool crab that can grow up to the size of a trash can lid. We strapped a camera on its back so you could see a crab's eye view of a forest floor. The crab cam lets us see the dense forest floor where lizards and other bugs hide under plants. This crab is called a coconut crab. And if you wonder how they got their name, they use their big claws to pull apart coconuts to eat the sweet meat inside. Coconut crabs can be sky blue, midnight purple, sunset orange, or fire engine red. They are the world's largest terrestrial or land-based invertebrate, which means they don't have a spine. When coconut crabs are babies, they live in the water and crawl into snail shells, kind of like hermit crabs, until their bodies harden.
That is super cool. So when I think of terrestrial or land-based animals, I usually think of mammals, like the squirrels that we see in our backyards. Crabs aren't the first thing that come to mind. So I know Palmyra must have other animals too. Can you tell us more about them?
Yeah, at Palmyra you'll find birds. There are 11 types of seabirds that fly above the atoll and nest in the forest canopy or on the ground. The seabirds hunt for fish near and far and bring their catch back to the island to feed themselves or their chicks. And here's something kind of gross, but also really interesting. Seabird poop, which is also called guano, is important for the island. The guano, along with dropped fish and dead birds, brings nutrients from the ocean to the land. Some of the nutrients are used by Palmyra's plants, and the plants in turn support all the animals, such as land crabs, geckos, and insects. Palmyra's heavy rainfall, almost 200 inches per year, slowly pushes the remaining nutrients back into the ocean where they came from originally. In the ocean, these nutrients support a huge food chain that includes algae, coral, other marine invertebrates, fish, and more.
It sounds like everything on the island is connected. Everything on land is connected to the ocean, and everything in the ocean is connected to what happens on the land. So now that we've heard about some of the animals, let's learn what it's like to be a human living on this remote atoll.
Let me tell you, it's pretty fascinating. Because it's so isolated, Palmyra is perfect for studying how a marine ecosystem responds to climate change. Plus, there's no overfishing or pollution here. But the scientists would not be able to do their important research without power. Every day, they're investigating coral reefs, atoll vegetation, marine life such as sharks and manta rays, and many other organisms. At Palmyra, we used to use generators to power our computers, lights, and refrigerators. The problem with generators is that they use fuel to run, just like a car. And the problem with fuel is that once you use it up, it's gone forever. That's why we call fuel a non-renewable source of energy.
So why can't non-renewable resources be replaced? And what exactly, are examples of other non-renewable resources?
Well, that's a great question, Jacqueline. We call oil, natural gas, and coal fossil fuels because they literally come from before the time of the dinosaurs. Over billions of years, organic material gets heated and compressed under layers and layers of plants and rocks and earth until it turns into a liquid oil, natural gas, or coal. There's a limited supply of fossil fuels on Earth, and we can't wait billions of years for more to form. We're simply using these resources up far too quickly.
So I understand that Palmyra made some pretty dramatic changes that drastically reduced their dependence on non-renewable energy sources. So can you explain how did they do that?
Let's take a look at this incredible renewable energy project. In June of 2015, Nature Conservancy staff and a crew of 30 volunteers completed their project on the atoll. Part of the project included installing 385 solar panels. These have provided Palmyra with an amazing source of renewable energy. Unlike fossil fuels, the sun's energy never runs out. That's why we call it renewable. It keeps delivering energy day after day, no matter how much we use it.
Wow, that's a big project. Installing 385 solar panels sounds like a lot of work. It's amazing the difference you made on the island in less than a year. So on Palmyra, the scientists are also using another type of renewable energy. Right now, we're watching a video about how they built a machine called a wind turbine to collect something else that can never be used up: wind. Now, Palmyra's wind turbine, which you see in this video, is rather unusual looking. Its hourglass shape has big, wide wind scoops on each end. The spinning blades are enclosed inside the turbine. Here's what a normal wind turbine looks like. See how it's very tall with 3 large blades designed to spin as the wind blows through them? A turbine is a type of engine. The wind turns the blades, which spin a shaft, which connects to a generator and makes electricity. Some large wind farms may have several hundred turbines providing power to a large area. I bet some of you have seen these. They might look strange like big windmills, but like we just talked about, they have a very important purpose. But on Palmyra, they can't use a normal wind turbine. Alex, can you explain why not?
Well, because of birds. A traditional wind turbine could be dangerous with so many birds zooming through the air. They could fly right into the blades. Palmyra is home to hundreds of thousands of nesting seabirds, including the second largest colony of red-footed boobies in the world. Other bird species include frigate birds, the males of which can inflate their red throat pouches to attract females. There's also a colony of 20,000 black noddies, the largest in the Central Pacific. Palmyra is one of the world's most important winter feeding grounds for the bristle-thighed curlew, a large shorebird that breeds in northwest Alaska during the summer and then flies non-stop to remote islands in the Pacific Ocean to feed on invertebrates and fruit.
That makes a lot of sense. If the team on Palmyra installed solar panels, why did they need a turbine as well?
Well, that's a great question. The wind turbine acts as a backup energy generator. It provides energy at night and during bad weather or heavy cloud cover, when the solar panels can't provide enough energy.
The Palmyra Atoll is a pretty small place. Can you tell us why using renewable energy there is such a big deal?
Yeah, it's true. Palmyra isn't very big when you look at it on a map and compare it to other places, such as a large city. This project was really important for the atoll because back when the island was powered by diesel generators, the amount of diesel fuel it took to run everything, 21,000 gallons a year, was eating up over half of our budget for the research station. Plus, it was producing over 349 metric tons of carbon dioxide every year. By turning towards renewable energy, we were able to spend less money on fuel, which means more money for research and conservation activities. And we are putting less carbon dioxide into the atmosphere.
So what's the relationship between fossil fuels and carbon dioxide? And can you help us to understand just how much 349 metric tons of carbon dioxide is?
Yes. Fossil fuels like coal, oil, and natural gas can be harmful when they are burned because they release emissions in the form of carbon dioxide and other gases. Even though we can't see carbon dioxide, it does have mass. To help you think about how much 349 metric tons of carbon dioxide is, 1 metric ton of carbon dioxide would fill a sphere over 10 meters in diameter. So in 1 year, that's 349 of these giant spheres of carbon dioxide being put into the atmosphere, just from Palmyra. We'll talk more later about how that contributes to climate change.
Okay, students, I hope you've been typing some of your questions in the box because Alex is going to answer a few very soon. Meanwhile, let's go visit our classroom in Somis, California. They've been studying renewable energy and they're going to share some really cool facts with us.
Hi, my name is Ricardo, and you can use the heat of the sun to cook your food.
Hi, I'm Gabby, and in 200 BC, people in China and the Middle East used windmills to pump water and to grind grain.
Hello, my name is Jonathan, and the country of Denmark has a plan to end the burning of all fossil fuels by 2050. This also includes electricity production and transportation.
Those are some awesome facts, you guys. Thanks so much for doing that research and for sharing them with us. Plus, that would be great if Denmark could reach its goal. Now, let's take a moment to answer a few questions from students who are watching today from all across the country. And you know what? I think we can start with this one. Here's a question for you, Alex, from a student named Eric. And he's asking, what do you like about being a scientist?
What I like most about being a scientist is that I get to ask questions and then go and try to find the answers to those questions. And well, for me, the kind of science that I really enjoy is biology. So I get to work with really interesting animals and ecosystems, which are the relationships between animals. And so it's really an enjoyable thing.
Yeah, it sounds really enjoyable. And we have another question from a student named Amara. And the question is, what is it about the poop and dead fish that brings nutrients to the island?
Awesome question. So the poop from the seabirds, called guano, and the dead fish that the seabirds bring back bring the nutrients that are collected out far in the ocean where the fish are feeding. So the seabirds, they nest on land, but then they go out into the ocean to feed. And when they're out in there, they're eating squid and fish, and they bring the nutrients that are captured in the bodies of those squid and fish back to the islands. And that's how the islands get their nutrients.
Got it. And now it makes even more sense how the ocean and land are connected. So you guys, those were some great questions from all of you, and we'll answer a few more at the end of our program. Now we're going to head to our second destination, the Mojave Desert, which is quite different from the Palmyra Atoll. While Palmyra is tiny, the Mojave Desert is a massive area of land. Here, the story is all about solar energy, and lots of it. The Mojave includes the lowest point in the U.S. Badwater Basin in Death Valley is 282 feet below sea level, while the Panamint Mountains soar to over 11,000 feet above sea level. Death Valley is the hottest and driest spot in North America. You can imagine that the sun shines brightly here. Now, let's get a sneak peek of the Mojave Desert. Wasn't that incredible? As you can see, the Mojave Desert is really different from Palmyra. The trees and animals have had to adapt to a completely different environment. Alex, can you tell us why we're visiting this dry desert landscape?
Well, the Mojave is one of the most promising areas in the world for developing solar energy, since the sun pours down on a really vast area of land. It provides us with an amazing opportunity to generate a huge amount of energy. The continental United States is much larger than Palmyra Atoll, and its energy needs are obviously very different with a population of nearly 320 million people compared to the 20 or so people at Palmyra.
Isn't it crazy to think that there are fewer people living on Palmyra than there are students in your own classroom? It's fun to put that into perspective. So Alex, how much energy can actually be generated by solar power?
Well, Jacqueline, it's really limitless. But here are some numbers to help us wrap our heads around it. It takes 32 acres, which is half a square mile, of solar panels to meet the needs of 1,000 homes. 32 acres is about the equivalent of 16 to 20 city blocks. If we set up a solar power generating unit in a desert with a 100 square mile area, we could supply enough electricity to meet the needs of the entire United States. Now, I'm sure some students are wondering how solar panels actually work.
Yeah, I'm sure they are. So we'd love to hear that explanation.
Well, solar cells, which can also be called photovoltaic or PV cells, are mostly made from silicon, a common chemical compound that's found in sand. We have giant solar modules in the Mojave, but you can even find small solar cells in digital watches and calculators, and they work the same way. Here's how they work. Sunlight is made up of tiny packets of energy called photons. These photons radiate out from the sun, and about 93 million miles later, they collide with a semiconductor, or a solar panel here on Earth. It all happens at the speed of light. Take a closer look and you can see the panel is made up of several individual cells, each with a positive and negative layer, which create an electric field. It works something like a battery. So the photons strike the cell, and their energy frees some electrons in the semiconductor material. The electrons create an electric current, which is harnessed by wires connected to the positive and negative sides of the cell. The electricity created is multiplied by the number of cells in each panel and the number of panels in each solar array. Combined, a solar array can make a lot of electricity for your home, or any kind of building. This rooftop solar array powers this home, and the array on top of this warehouse creates enough electricity for about 1,000 homes.
Wow, that's a great explanation, and it was really helpful. I've definitely seen solar panels where I live, and students, you might have too. Sometimes it looks like a reflective rooftop. So Alex, are there other types of solar power facilities in the Mojave?
Yes, there are. Another type of solar technology involves mirrors that reflect sunlight onto a power tower, which concentrates all of the sunlight. This heats up water inside the tower, which produces steam, which turns a turbine and generates electricity. This is called concentrating solar power.
And Alex, you mentioned that the energy that could be generated from solar power is limitless. Can you tell us more about that?
Well, it truly is limitless. The sun is a giant ball of fuel that's going to blaze for the next 5 billion years. It literally could power every energy need on Earth and not even flinch, so to speak.
Imagine all the things we use every day that need energy. Students, now is your time to chime in. Just use the Q&A section to tell us what items in your home or school use energy. In the meantime, Alex is going to share some facts with us, and we'll come back to your answers shortly. Alex, what are the facts that you had in mind?
Okay, Jacqueline, here is a neat fact. The Earth gets more energy from the sun in an hour than is used in the entire world in 1 year. We just need to harness all that renewable energy. The same goes for other renewable sources of energy, including wind energy, like we saw at Palmyra.
Wow, it would be amazing if we could completely rely on renewable sources for all of our energy needs. Imagine a world that wouldn't have to use oil or gas or other non-renewable sources of energy. So students, I see some of you use the Q&A section to tell us what items in your home or school use energy. I see computers, televisions, toasters, tablets, microwaves. These are all great answers. Good job. Alex, since we can't rely on renewable sources for our energy needs, what are we doing instead?
Well, that's a great question, Jacqueline. At the Nature Conservancy, we've been working hard with the US government and other organizations to try and help develop renewable energy projects while protecting nature. Some of these projects impact areas a lot bigger than Palmyra Atoll. For example, the state of California has the highest population of all the states, almost 40 million people, and that means it has a huge energy demand. There's a state law in California requiring that 1/3 of the state's energy be from renewable sources by the year 2020, and that's not very far away. This work is important to us because we want to have clean energy so that we can have clean air, clean water, and protect Earth's climate. We also want to protect the desert wildlife and habitats. Our studies have shown that it's possible to have clean energy and protect nature. There's no reason to have to sacrifice one for the other. It's important to find ways to have both.
Can you explain a little more about the relationship between fossil fuels, carbon dioxide, and climate change?
Fossil fuels like oil and gas are not only non-renewable, the emissions these fuels give off alter the climate. Climate change affects all life on Earth, including us. Of course, this makes it important that we continue to expand the use of renewable resources around the world. This energy plan for the state of California is such a giant step, but it's only the beginning.
So let's take a moment for a quick pop quiz. I'd like students who are watching to let us know a few ways in which your schools or communities are using renewable energy sources or helping nature in other ways. If they're not, what would you like to see happening? Type your answers. Students like you really do have the power to make a big impact on preserving and protecting nature. There are things you can do right now. You can write letters, talk to adults, do further research, and more. We're curious to hear your ideas. Now, I see that Kyle says his dad's small business is powered by solar panels. I think that's wonderful. And I know that some students who are watching walk to school every day instead of riding in a car, and that's super helpful too. So try to think of some more examples that you do every day or that you see in your community, and let's talk about it. Now, Alex, the Mojave Desert has millions of acres of land and covers parts of California, Nevada, Utah, and Arizona. How do you use this knowledge to decide where to locate the solar panels?
Well, that's a really good question. First of all, the Mojave Desert is truly one of the world's last great places. Its scenic beauty and natural wonders shelter a huge range of plants and animals, and its 20 million acres provide for people in a multitude of ways: clean water to drink, fresh air to breathe, and energy to power our lives. So the Nature Conservancy's priority has to be protecting and preserving the special habitat and the wildlife that lives there. The energy nature provides from the sun and wind may seem green, clean, and like the perfect alternative to non-renewable energy sources that produce greenhouse gases and contribute to climate change. Even renewable resources can have their impacts. So smart planning is really important. First, when deciding where to develop a solar energy facility, we determine where the most solar power can be harnessed. At Palmyra, we chose to locate our solar array on the rooftops because we didn't have a lot of land to work with, and this was the least disruptive to the habitat.
That makes sense. What about in the continental US? What would influence your choice then?
Well, in the continental US, you would want to pick from an area with a lot of sun or solar radiation. Look at this map of the US. The orange colors indicate the potential for solar power. The orange colors show where sunlight is received, and the darkest orange indicates the most sunlight. So the darkest orange areas are the best for solar sites. And the Mojave Desert is right in the middle of the darkest orange.
I'm sure that it's not that simple though. The amount of sun is one thing to consider, but aren't there a lot of animals and plants living out there too?
That is true. Once you pick the area with the most sun, you need to figure out what lives there. The same qualities that make for a good site for a solar facility can also be important for wildlife. For example, desert tortoises are amazing reptiles that live in the desert and need a lot of the same things as solar facilities. Lots of sunny, flat land. The tortoises have adapted to live in the extreme temperatures of the desert with very little water. They live much of their lives underground in burrows. This is where they hibernate during the cold winter months because in some of the deserts where the tortoises live, like the Mojave Desert, it gets cold enough to snow. They spend the hottest part of the day in their cool burrows, but come out in the morning and afternoon to eat plants. When we are building these solar facilities, we need to pay attention to the fragile ecosystems that are home to animals like desert bighorn sheep and desert tortoises and bald eagles. A solar array can be as large as downtown San Francisco, so if you put that down in an area that's heavily populated by a threatened species like the desert tortoise, you're going to destroy their habitat. We need to protect the wildlife at the site, the plants, and the ability of the animals to move around freely.
Do you ever just find barren desert areas to build where there isn't going to be a negative impact on plants and animals?
Yes, we do. Sometimes it's possible to put solar panels on land that has already been disturbed, like an abandoned mining field or an old farm, where wildlife and plants are not thriving. Building a solar facility there would have much less impact, and desert habitats won't be damaged.
So before I asked you why it was such a big deal to have renewable energy in a place as small as Palmyra, and you had a great explanation, it might be more obvious now why we need to use more renewable energy in the rest of the world. But can you help us to understand this even more?
Well, right now, a great portion of our energy comes from burning coal, natural gas, or oil. In the US in 2015, 67% of electric power came from coal, natural gas, and petroleum. Only 13% came from renewable sources like solar and wind. And the remaining 20% came from nuclear power. As we've discussed, these are non-renewable fossil fuels. They take millions of years to form. We use them faster than nature makes them, and their emissions contribute to climate change. We can see how a relatively small project at Palmyra Atoll can lead to such dramatic changes. Then you look at the energy transformation that's happening on a much larger scale in California. This shows the massive potential of renewable energy. Soon we can imagine that transformation spreading out across the entire United States and throughout the world.
You're absolutely right. We need a renewable energy solution for the entire planet. Some of the changes are happening at the city, state, and even global level. But what could one of our student viewers do to make a difference?
Well, the cleanest energy of all, and the energy that has the least impact on wildlife, is the energy that we do not use. Every time you turn off lights, or the TV, or a computer when you leave the room, you are saving energy. And when you save energy, that means that we don't have to make as much. So you are not only helping to protect the desert critters, but also reducing the need for more dirty energy like coal. You can also ask your parents what kind of light bulbs you have at home. There are some new kinds of light bulbs, like LED bulbs, that use a lot less energy than old light bulbs. In fact, an LED light bulb uses 1/3 or less of the energy of a regular incandescent light bulb. If your energy comes from the burning of fossil fuels, then using an energy-saving bulb results in less carbon dioxide being released into the atmosphere. Using LED bulbs is an easy way to save energy, even when the lights are on. You can find LED bulbs in a store in your neighborhood.
Those are some great tips. I like the idea that the cleanest energy is the energy we don't use. Now, okay, it's time for a few more questions from our audience and our classroom. So Alex, do you have any examples of renewable energy sources in your own home?
Funny that you ask. Yes, we just signed up to have solar panels put on the roof of our home. And with the plan that was put in place, we're expecting that they're going to provide all the power that we need for our house.
That's really neat. And I have another question. We talked about solar power and wind turbines as well. But the students want to know what happens if the wind isn't blowing and the sun isn't out, like at nighttime. What happens then?
With our two energy generating systems at Palmyra, if the wind isn't blowing and it's nighttime, then we're not making energy from a renewable source. And so what we have are backup generators. But we also have a battery bank that stores energy, stores electricity. And so if we make enough electricity during the day with the wind or with the sun, then we can pull from that battery bank and hopefully the backup generators don't have to turn on.
That's interesting. So we can use renewable sources during the day and store that for at night. Got it. Now, another student wants to know just how hot does it get in the Mojave Desert? Do you know what temperatures it might be right now?
That's a good question. Right now, I don't know what temperature it is, but I'm sure it's pretty hot, and I know it can get well over 100 degrees Fahrenheit there.
Wow, that is hot. Now, students at Fairview Elementary in Indiana, they want to know how many years did it take to become a scientist?
It took quite a few years. Well, you know what? I'm going to answer this a different way. The only thing you need to do to be a scientist is to ask a question and then find a process for answering that question. So to really be a scientist, you just have to be inquisitive and then follow through with how you answer those questions.
And Evan wants to know, what is your favorite bird that lives on the island?
My favorite bird at Palmyra is the white tern. It's a beautiful small seabird that's bright white, and it flies right above your head and makes funny noises.
And what's your favorite part of, being on Palmyra?
My favorite part about being on Palmyra is being able to be so close to so many amazing animals, both in the water and on land. And these are animals that don't really occur very often near populated areas. So we can really only see them and watch their behaviors at places like Palmyra.
And how many times a year do you go to the island?
Well, I'll probably go to Palmyra about 4 to 5 times per year.
And I think that we have one more question coming from our classroom. Classroom, are you ready to ask Alex your question?
Hi, my name is Sammy, and I was wondering, since Palmyra is surrounded by water, have the scientists there tried to harness the power of the ocean too?
Hi, Sammy. Thank you for that really good question. Well, we have thought about it at least, and we know the energy that we can harvest from the ocean. I mean, we know that it's possible to do that. You can harvest energy from waves or ocean currents. But right now, we can meet most of our energy needs at Palmyra with solar and wind power. And so we haven't had the need to add a wave or ocean current power generation system. But you know what? I think we'll definitely keep that on the table, and we'll think about that in the future if our power needs increase.
Alex, for such a system, what would we have to keep in mind? Like, how would the system affect the ocean environment?
Well, there could be impacts to the behaviors of the animals that live in the ocean, or we may have to disturb some of the habitat on the ocean floor if we have to install hardware down there to collect the energy. And so the same considerations that we have for putting solar panels in the Mojave Desert, we would have to think about the same things for putting some kind of energy collection device on the floor of the ocean. We want to make sure that we did it in a way that did not harm the wildlife.
Yeah, that makes sense. And students, thank you so much for joining in, and that's about all we have time for today. But thank you, Alex, for joining us. This was really fun, and thank you for helping us understand how renewable energy sources can protect our natural spaces and life on our beautiful planet Earth.
Thank you all so much for having me.
And let's also say thank you and goodbye to the students at Somis Elementary. Thanks for joining us, students. And I hope you all had fun playing Nature Spy today and spotting all types of intriguing creatures, feathered, furred, and scaly. Did you find all the items on your worksheets? I hope so. I hope you also take this a step further and play Renewable Energy Spy in your communities. Thanks again to Lowe's for providing support for today's virtual field trip, and thanks to you all for tuning in. Don't forget to check out the teacher's guide and other resources on our event page, or by going to the link on screen for more activities related to this trip. And remember, you can access this recording at the same URL anytime. Thanks for joining us. Until next time, goodbye.